Yesterday we extended our concepts of the unit circle to include the tangent of an angle as well. And what we have in general now, folks, that if we have a unit circle, and if we know the coordinate where the terminal side of our angle, how do we distinguish the terminal side of our angle? Where the arrow ends. If we know the coordinate of that terminal side and where the unit circle intersects, then that x, y coordinate are going to define both the sine, cosine, and now the tangent of our angle. The x coordinate defines what? Cosine of theta. The y coordinate is sine theta, and tangent is y over x. Okay, and then going along with that, then we were able to determine in what quadrants sine, cosine, and tangent would be positive or negative in by relating it to where the x and y coordinates are positive and negative. And then what was that quick acronym that we had to remember where our quadrants were positive? All in quadrant 1. What does the S stand for in quadrant 2? Sine. The T in 3? Tangent. And the C in 4? Cosine. Work back to front. These are just straightforward law cosines, law sines, and then you got your arrows. So I'd work back to front. You got your cheat sheet as well. Okay, just take it off there. Okay. So again, all students take calculus, tell us where the trig functions are positive in which quadrant. So we had that, I believe, was what, 7 through 29 odds? Is that correct? So 7, 9, and 11, there were going to be 2 quadrants, and then in the next section we could narrow it down to 1. So 7 has to be 1 and 2. 1 and 2. 9 is 1 and 3. 11 is 2 and 3. 13 narrows down to quadrant 3. 15 is quadrant 2. 17 is quadrant 4. 19 is the table then, so your sine column should go positive, positive, negative, negative. Your cosine should go positive, negative, negative, positive, and then tangent should alternate positive, negative, positive, negative. Number 21, where is tangent undefined again? 90 and 270. Now, why is it undefined there? The x-coordinate is 0. Tangent is defined to be y over x. The x-coordinates are 0 at 90 and 270, so tangent will be undefined. 23. Sine theta is the y-coordinate, negative 0.8. B, cosine is the x-coordinate, 0.6. And then C, tangent is y divided by x. So you could have negative 0.8 divided by 0.6, but folks, is a fraction in simplest terms if it has decimals? No, it's negative 4/3. Negative 4/3. And actually here for part A, I would prefer negative 4/5 and 3/5. Can you turn a decimal to a fraction? Absolutely. So negative 4/5, 3/5, negative 4/3 for C. 25. Again, the cosine is negative 3/5. The cosine is negative 4/3. So the tangent then is this divided by this. Well, a negative divided by a negative becomes a positive. And folks, we don't divide by 4/3. We multiply by how do you divide fractions, folks? You multiply by the reciprocal. So when we multiply by the reciprocal, then we get our 3/4. 27 and 29 were multiple choice. 27 is choice 1. 29 is choice 4. Choice 1 and choice 4. Do we need any repeats? Individuals you have questions on? 23. So 23 says that the points A and B are on a unit circle. If the measure of angle AOB is equal to theta, they want us to find the sine, cosine, and tangent then of theta. And again, we know that sine is defined to be which coordinate? The y-coordinate. Cosine is defined to be the x-coordinate, and tangent is defined to be y over x. So we know here that sine is y, that cosine is x, and that tangent is y divided by x. So let me sketch this unit circle here real quick. Here's a crude drawing of our unit circle. So here's the point A at 1, 0. And then we've got the point B, which is 0.6, negative 0.8. What quadrant is that in, folks? It's got to be in quadrant 4. We got a positive 0.6, then a negative 0.8. So right here is the coordinate of B, 0.6, negative 0.8. So we've got this angle AOB, which they have defined to be as theta. Now, does it matter if we rotate counterclockwise or clockwise? No, ultimately that doesn't matter. I'm just going to go right here and say that that's our angle theta. So then, folks, which is the terminal side of this angle theta? The OB is the terminal side, so B is the coordinate that we're focused on. Okay. This XY coordinate is the coordinate we're focused on because that's the point where the which side intersects the unit circle? The terminal side. Initial side doesn't matter. The terminal side is what we're concerned with. So what is the sine of this angle then? You told me up here the sine is which coordinate? The y coordinate, so we get negative 0.8, which a better answer would be negative 4/5. What is the cosine of our angle equal to? Yeah, the x coordinate, which is 0.6, or a better answer would be 3/5. And then tangent, you told me, was y divided by x. So our y coordinate was negative 4/5. Now we're not going to divide by 3/5. We're going to multiply by the reciprocal 5/3. And what will happen to the 5s? They'll cancel out, giving you negative 4/3. Giving you negative 4/3. Okay. So negative 0.8 or negative 4/5, 0.6 or 3/5, and then negative 4/3. Folks, you would not get credit if you had this. From elementary school, we know that's not simplified. We don't want decimals in our fractions. We've got to simplify that down. Negative 8/6 would be equivalent, but not simplified. We want negative 4/3. All right, with 23? Good there. Other questions we have, folks? Which one? 29, the multiple choice one. So 29, they're asking us which of the following statements is false. So the last thing we had in our notes yesterday is we said that the function values of coterminal angles were equal to each other. Okay. So I want to look at these two and say, well, is 300 and negative 60, are they coterminal? What do they have to have a difference of if they're coterminal? 360. So what's 300 minus negative 60? Minus a negative becomes plus a positive, and that's 360. So are these two coterminal angles? Yes. So are these two going to be equal to each other? Yes, they are going to be equal to each other. Okay. How about number 3, 90 and negative 90? Are they coterminal to each other? Let's look here. 90, or that negative 90 would be the same as what? I don't really want to deal with the negative angle, so I'm going to add what to it? So I'm going to add 360 to it. What's 360 minus 90? 270. That's 270 degrees. So this is really here the cosine of 270 degrees. We want to see if the cosine of 90 is going to be the same as the cosine of 270. Well, 90 degrees is right up here, right? 270 is right down here. What's the coordinate up here? 0, 1. What's the coordinate down here? 0, negative 1. Cosine is which coordinate? The x's. Are the x coordinates the same at both of these spots? Yes, they are. So is the cosine of 90 going to be the same as the cosine of negative 90? Yeah, they're going to be equivalent to each other because both of the x coordinates there are 0. How about the sine of 90 and the sine of negative 90? Sine is which coordinates? The y's. Are the y values the same at these two spots? No, they are not. Is the sine of 90 going to be the same as the sine of negative 90? No, it is not. This is the one That is false. Choice number 4. Okay. Number 2, are these ones coterminal? Yes, they are. So they've got to be equivalent to each other. So it's number 4 because up here the sine of 90 would be 1. The sine of negative 90 is negative 1. Those two things are not equivalent to each other. All right with 29? Good. Other questions we have, folks? 27, the other multiple choice one. Again, we've got point on a unit circle. Says points A and B are on the unit circle. The coordinates of A are 1, 0. So let's quickly sketch this out. So here's my unit circle. Here's the point A at 1, 0. What quadrant would point B be in? Negative, positive? Would be over here in quadrant 2. So right here is going to be B at negative 1/2 radical 3 over 2. So here is then that angle AOB. And they say that the measure of angle AOB measures how many degrees? So this is a 120-degree angle down here. And ultimately, then what they're asking me for is the tangent of this 120-degree angle. Okay. How did we define tangent in terms of our coordinate? It was the y-coordinate divided by the x-coordinate. Now, which coordinate are we looking at, the A or the B? Why the B coordinate? That's the terminal side. This is the terminal side, so this is the coordinate we're concerned with. So what is our y-coordinate? The y-coordinate? Radical 3 over 2. What is the x-coordinate? Negative 1/2. Now, folks, we're not going to divide by negative 1/2. We're going to multiply by 2 over 1. Now, is that still negative, though? Yes, a reciprocal keeps your sign. It's still a negative. Okay. What's going to happen to the 2's? They're going to cancel out. What's a radical 3 times a negative 1? A negative radical 3. The tangent of 120 degrees, then, is choice 1 at negative radical 3. We've got to take the y-coordinate and divide it by the x-coordinate. Okay. All right with 27? Anything else off of the homework, folks? Okay, so very, very, very important concepts here, folks. If we know the point where the terminal side intersects that unit circle, then the x-coordinate defines which trig function? X is cosine, y is sine, and tangent is y over x. Very, very important concepts. Very important concepts. Okay. If there are no further questions, go ahead and put that to the side and hand that in as you are exiting today. Into section 14.6. I'm sorry, I guess before I get ahead of myself, tomorrow, quiz, everything up to what we've just covered. Okay, so again, x-coordinate defines what? Sine. Y-coordinate defines sine, and tangent is y over x. When do you use Pythagorean theorem? Sides. When can you use baby trig? When there's an angle involved or you need to find an angle. Now, when I say baby trig, I'm referring to what? SOHCAHTOA. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. Now, that can only be done in what kind of triangles? Right triangles. Where's the hypotenuse? Always across from the right angle. Where do you find the adjacent side? Yeah, it's connected to the angle. The adjacent and the hypotenuse always form your angle. The opposite of them is obviously opposite of that. So quiz tomorrow, sections 1 through 5. Sections 1 through 5, like what we've been seeing in the homework last night. So know that sine is the y-coordinate, cosine is the x-coordinate, tangent is y over x. Know your quadrants. How do you remember your quadrants? All students take calculus. All students take calculus. Okay. So for today then, for 14.6, the goal for us today is to fill in this table. These are our special angles in trig. The 30, the 45, the 60, and then the quadrantal angles of 0, 90, 180, 270. Now 0 is also the same as what? 360. 0 is the same as 360 as well. Okay, so all of our quadrantal angles at 0, 90, 180, and 270, and we already know their function values because we know the unit circle. We already know 0, 360, 90, 180, and 270. But then we got these 30, 45s, and 60s, and why are they special angles? Well, in geometry you had the two special triangles of the 45, 45, 90, and the 30, 60, 90. We're going to go back to those concepts today and find out what the sine, cosine, and tangent of these angles are going to be. And notice down here I've got this table must be memorized. Folks, your knowledge of this table is going to become extremely important in Algebra 2 Trig and any continued mathematics course that you take. You are going to need to know the function values of these angles like the back of your hand. Ask any of my calculus, pre-calculus students, they will be able to tell you this. Boom, 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 boom. Okay, this table must be memorized up to the 90. Now, it's not 15 different numbers that you're going to have to memorize. There's going to be a trick to knowing this table. If you know this line right here, you know the whole table. So it's not memorizing 15 different values. It's just memorizing this sine line. If you've got that sine line, you've got the whole table. Okay? Now, how are we going to get these values then? Well, we're going to start with the unit circle. We're going to start here with the unit circle and define our 0, 90, 180, and 270. Because we know that sine is which coordinate? The y coordinate. Cosine is the x coordinate. And tangent is y over x. So let's start with our 0 degree angle. Our 0 degree angle would do this one in black. Our 0 degree angle would start here on the initial side and then go right back to here. So this coordinate right here is where the terminal side intersects the unit circle. What is the cosine of a 0 degree angle? 1. What is the sine of a 0 degree angle? 0. Well, let's go back in and fill that in then. Okay. You said the cosine of a 0 was 1 and the sine of a 0 was 0. Okay, easy enough. Okay, let's extend that now up to a 90 degree angle. And I'm going to keep this one in black so I've got the 90 as well. So the 90 is going to start right here and go to the origin and then go up to this point up here. This is the coordinate where the terminal side intersects the unit circle. What is the cosine of a 90? 0. What is the sine of a 90? 1. Let's fill that in. 90 degrees, you said the cosine was 0 and the sine was 1. Okay. Any questions on this, folks? Okay, easy enough. I'm waiting for tangent because tangent is what over what? Y over x, the sine value over the cosine value. So once I get the sines and cosines in, I'm just going to look at the table and divide them out to get those values. Okay, I've got 180 in red. So let me change this to red. So 180 would start here, go to the origin, and then go right over to here. So the coordinate that we're looking at over here is the negative 1, 0. What is the cosine of 180? Negative 1. What is the sine of 180? Let's go and fill that in. 180. The sine is 0. The cosine is negative 1. Okay. So looking now at the 270, we're looking at this coordinate down here. What's the cosine of 270? 0. The sine of 270? Negative 1. So sine was negative 1, cosine was 0. Nothing new. We've already seen this the last 2 days. Okay? And now that we said that tangent is the y value over the x value. So what is 0 divided by 1? 0. We can divide by 1. 0 divided by 1 is 0. What's the 90? The 90 is going to be undefined. Which other one's going to be undefined? The 270 is undefined. And the 180 is again going to be 0. Yeah, 0 divided by anything is going to be 0. So those were the easy ones because we've got them from the unit circle and we know sine is the y coordinate, cosine is the x coordinate, and tangent is y divided by x. Okay. So that's why I started with sine and then went to cosine, because tangent is sine divided by cosine. It makes the table look a little easier like that. Okay. Now the next one then, how are we going to take care of these 45s? Well, we're going to look at an isosceles right triangle. What does isosceles mean? Two sides are congruent. Well, if we're dealing with a right triangle, what are the two sides that have to be the congruent ones? The two legs are the ones that have to be congruent. Because the hypotenuse has to be the largest side. And can I have a side that would be the same as the hypotenuse? No, we couldn't. Okay. Now, understanding from geometry then, if two sides of a triangle are equal in measure, then what do we know about the two angles opposite of them? They've got to be equal in measure as well. So this angle right here, these two acute angles have to be the same. Tell me what their measure has to be then. They've got to be 45s. This is a 45, 45, 90 right triangle. So up here's a 45-degree angle, down here's a 45-degree angle. And now we're concerned with sides. Well, I don't know any of the side measures, so what I'm going to do is I'm going to make this the easiest case possible. What would be the easiest length? 1. So I'm going to say that these two sides have equal lengths and they measure 1 unit. Could I have put 8 down there? Could I have put 15 down there? Does it matter what we put there? Why did I put 1s? Easy to work with. They're easy to work with. So folks, we've got a right triangle here, and I ultimately need to know what this side over here is. Right triangle trig or Pythagorean theorem? Pythagorean theorem, because we know the two legs, right? So how would we find the hypotenuse then? What would we set up? 1 squared plus 1 squared equals hypotenuse squared. What is 1 squared? So 1 plus 1 is 2. So the square of my hypotenuse is 2. How do we undo that square? We take the square root. So the hypotenuse is radical 2. Why not negative radical 2? Yeah, sides can't be negatives. We're only looking at positive sides here. So this is a radical 2. That's a radical 2. So now that I know all three sides of this right triangle, now I'm going to go to baby trig. And what I'm going to do, folks, does it matter which of these acute angles we reference? No, why not? Because they're the same. So I'm going to come down here and I'm going to highlight this one right here. This is the one I'm going to reference. So this is my hypotenuse. This would be my adjacent. This would be the opposite. Okay, so let's talk about then the sine of a 45-degree angle. Sine is defined to be what over what? O over H. Well, what is the length of my O? 1. What is the length of my H? Radical 2. So sine of 45 is 1 over radical 2. But can we have a radical in the denominator? No, we cannot. We took care of that in the first marking period this year. How do we rationalize this denominator? What do we have to multiply top and bottom by? Another radical 2. Yeah, we multiply the top and bottom by a radical 2. So up top, 1 times radical 2 is what? Radical 2. Radical 2 times radical 2 is radical 4, which is ultimately 2. So what is the sine of a 45-degree angle? Radical 2 over 2. Radical 2 over 2. Now, folks, is the cosine going to be any different? No, cosine is what over what? A over H. It just happens to be that my A was the same as the O. So this is also going to be 1 over radical 2, which will still be what? Radical 2 over 2. So the sine and the cosine of a 45 is radical 2 over 2. And now again then, tangent, we know tangent is what divided by what? Y over x or sine over cosine. Well, anything divided by itself is 1. Anything divided by itself is 1. So that's how we take care of the 45s. Sine and cosine of a 45 is radical 2 over 2. And the tangent is 1. Okay, so that was easy to take care of. Now the 30, 60, we are going to deal with an equilateral triangle to get these ones. What does equilateral mean? All sides and angles are the same. What are the 3 angles? They've got to be 60s. So this is a 60-degree angle right here. This is a 60-degree angle right here. I'm not going to label this one just yet because I'm going to do something to it, but this is a 60-degree angle up here as well. Do we know anything about the side lengths, though? They're all equal, but over here I decided to use what? 1, just because it was easy. So can I use 1s here again? Yep, let's use 1s again. 1, 1, and I'm not going to label this one down here as 1 because I'm going to do something to that as well. And what I'm going to do here, folks, is I am going to draw in an altitude. An altitude goes from one vertex to the opposite side, forming what kind of lines? Perpendicular lines which form right angles. So that's a 90-degree angle. Now, in an equilateral triangle, that altitude not only formed a 90-degree angle, it did 2 other things. What did it do to this side? It cut it in half. So instead of having 1, we've got what and what? 1/2 and 1/2. What did it also do to the 60-degree angle? Split it in half. So instead of 60, we've got 30 and 30. So what I'm going to do now then, folks, is instead of looking at this full triangle, I only want to look at that portion of it right there. Okay. And what I'm going to start by doing is I'm going to reference the 30-degree angle. Well, actually, I guess the first thing we've got to do here is find the length of this altitude. Do we have a right triangle? Yeah, we do. So can we use Pythagorean theorem to find this leg? Yes. We want to say a squared plus, what's my other leg? 1/2 squared equals, what's our hypotenuse? 1 squared. What is 1/2 times 1/2? 1/4. What do I have to do with this 1/4 to bring it over here? Subtract it. So what's 1 minus 1/4? 3/4. So a squared equals 3/4. How do we undo that square? So a is the square root of 3/4, which can simplify down. Can we simplify the 3? No, that stays radical 3, but can we simplify the 4? What's the 4 come out as? 2. So this leg over here has a length of radical 3 divided by 2. Radical 3 over 2. So I have a leg of radical 3 over 2, I have a leg of 1/2, and a hypotenuse of 1. Now, according to this 30-degree angle, which side is adjacent to it? The radical 3 over 2 is adjacent. Which side is opposite? 1/2 is opposite. And which is the hypotenuse? 1. Okay, so let's talk about then the sine of a 30-degree angle. The sine of this 30-degree angle is again equal to what over what? Opposite over hypotenuse. What is the length of my hypotenuse? My opposite, 1/2 divided by what's the length of my hypotenuse? 1. Well, 1/2 divided by 1 is 1/2. So the sine of a 30 is 1/2. Okay, you can go ahead and fill that in. The sine of a 30 is 1/2. The cosine of a 30. Cosine is what over what? A over h. So instead of 1/2 over 1, we have radical 3 over 2 divided by 1. Well, anything divided by 1 is itself, radical 3 over 2. So let's go ahead and fill in the sine and the cosine of a 30. Sine of a 30, 1/2. Cosine of a 30, radical 3 over 2. Now again, how do we get tangent then? Yeah, so what's going to be 1/2? We're not going to divide by radical 3 over 2. We're going to multiply by 2 over radical 3. What's going to happen to the 2's? cancel, and I get what over what? 1 over radical 3. But can I leave it like that, folks? No, I can't. What do I have to multiply top and bottom by? A radical 3. So what's 1 times radical 3? Radical 3 over radical 3 times radical 3 is radical 9, which is 3. Radical 3 over 3 is the tangent of our 30. Radical 3 over 3. Any question on how we got the 30s? It's from that 30, 60, 90 right triangle. Okay, and now with this same triangle now, folks, let me now erase the reference for the 30 degrees and look at the 60 degree. So now let's look at the 60 degree. Which side is adjacent now? The 1/2 is adjacent, which is opposite. The radical 3 over 2, hypotenuse is still the 1. Okay, so now let's talk about the sine and the cosine of that 60. Talk sine first again. Sine of a 60. Again, sine is what over what? O over H. So what would we get here? What's O divided by H going to be? Radical 3 over 2 divided by 1, which is just simply radical 3 over 2. Cosine of a 60 would be what over what? Yep, A over H, which would be what divided by 1? 1/2 divided by 1. Well, 1/2 divided by 1 is 1/2. Okay, so let's go and fill those in now. Here we had radical 3 over 2 and 1/2. Okay. And now again, how are we going to find tangent? Yeah, we're going to divide. So we're going to take the sine, radical 3 over 2, and divide it by 1/2. But again, folks, we're not going to divide by 1/2. We're going to multiply by the reciprocal. What will again happen to the 2's? They'll cancel, and it just leaves me with radical 3. Radical 3. Okay. We've got our table filled in. Now again here, folks, what you have to memorize is the sine, cosine, and tangent of the 0, 30, 45, 60, and 90. We've got to get this table memorized. Now I said it is not memorizing 15 different values. I said that if you can memorize these 5 values in my sine column, if you can memorize that sine column, you've got the whole table figured out. Explain that to me then. Why do I only need to know those 5? Sine and cosine are just opposites of each other, right? Sine goes 0, 1/2, radical 2 over 2, radical 3 over 2, 1. Cosine just goes backwards. Cosine is 1, radical 3 over 2, radical 2 over 2, 1/2, and 0. So if I know the sine line, do I know the cosine line? Yeah, I just reverse it. And then how did we get the tangents? We just divided. We took the sine and divided it by the cosine to get that. So is this 15 different values to memorize, folks? No. You've got to memorize that sine line. If you can memorize that sine line, then cosine is just backwards, and tangent is sine divided by cosine. So is there an easy way to look at memorizing these 5 values in the sine line? Yes, absolutely there is. Starts at 0 and ends at 1. So you've got a 0 at the beginning and a 1 at the end. The 3 in the middle are all being divided by 2. They're all being divided by 2, and their numerators go 1, 2, 3. Their numerators go 1, 2, 3. You just got to think of them as being radicals. Now, could I also think about this as being the square root of 1? Yeah, because the square root of 1 is 1. So how I memorize the sine line, 0, 1, all divided by 2, radical 1, radical 2, radical 3. But then radical 1 is 1. So if I've got the sine line, I then say, well, cosine is just backwards. So I'm going to go 1, radical 3 over 2, radical 2 over 2, 1/2, 0. And then tangent is dividing. 0 divided by anything is 0. I'm not going to divide by radical 3 over 2. I'm going to multiply by the reciprocal and simplify it. Anything divided by itself is 1. Again, I'm not going to divide by 1/2. I'm going to multiply by the reciprocal and simplify it. And then I can't divide by 0. It is undefined. If I know that sign line, I've got everything. If I know that sign line, I have everything. Okay, now, I said that's got to be memorized. How I make you memorize these is you will have a quiz every day on this table. You will have a quiz on this table every day until everyone in Algebra 2 Trig, not everyone in your class, everyone in both classes of Algebra 2 Trig gets a 100 on this. Does that tell you something about this table? It's important. You will take a daily quiz on this table from here to there. I don't include the 180s and the 270s. Just what I've got bracketed here. You will take a daily quiz on this until 21 of you get a 100 on it. Now, some of you will get a 100 on the first time. Do you have to keep retaking it? Yes, you do, until everybody gets a 100. Now, does everybody have to get a 100 on the same day? No. Not everybody has to get a 100 on the same taking of it. It's just we have to take it until everybody on my grade report has a 100 on there. Now, are you getting counted as multiple quizzes? No, it's in there as one grade. It's in there as one grade. It's just that we have to take it until everybody in my grade book, 21 students, have a 100 on this. Vital. It's important. When is the first time you're going to be taking it? I am going to include it on tomorrow's quiz, but it's only going to be a practice. It's only going to be a practice tomorrow because we really need to focus on the regular quiz tomorrow. The first one that will count will be Monday, right? Today's Thursday. So the first one that will count will be Monday. It will be on there tomorrow, and I'm going to put it on as a bonus tomorrow. So if you've got it all completely correct, I'm going to give you bonus tomorrow. But I really want you focusing on 14:1 through 5 tomorrow. But eventually, we all have to get a 100 on this, not at the same taking. Now, if you get a 100 the first time, should you get anything but a 100 on the times where you take it? No. Once you've got it, you should have it. If you've already got a 100, you've already got a 100. You still have to keep taking them, but you've already got the credit for the 100. Yes, once you get the 100, I put it in the grade book, and that's how I look at it. Is beginning of each class, I look down at the grade book, and if there's somebody that still doesn't have a 100 in either class, we take it again. Okay? The least I've had is 4. Beat it. Okay? The least I've ever had is 4. 4 tries. I want you guys to beat it this year. Okay? This is the smallest group of Algebra 2 I've ever had. Okay, and that even goes into Math B in Course 3. I've always quizzed this. 12 years of teaching this, done the same thing all 12 years. This is that important. Least we've ever had is 4. Okay? Beat it. Beat it. If everybody can get it on the bonus tomorrow, we'll be done. We'll be done. If everybody gets it on the bonus tomorrow, we'll be done. I won't even give you the official one Monday. Okay? You've got to have these memorized, folks. It is vital to your continued stuff here in Algebra 2 Trig. Operations with fractions, we've really got to recall these. These are very important. How do you add or subtract fractions? You must have a common denominator. You know what? Let me just pick up on this point here tomorrow. Your only homework tonight is to study for your 14.1 through 14.5 quiz and review these values for the bonus of it. I'm only going to give you bonus if it's all correct, though. Okay? And I've got 16 after. Drop your homeworks off, and you are out. Study, study, study. Test corrections are also due tomorrow, folks. Don't forget those. Have a good one, guys. Thank you.